Well, it is 3:30, and we can pick up again. I think I'd like to try to, we've been talking about fire safety and especially on detection and detection of fire signatures and instrumentation that would be quick enough, informative enough, and accurate enough to really say some things about the atmosphere. I think that we've just from what's in the chat that could be an area that, or at least proving whether that's an area that needs to look at differences. That there's differences in that signature between Lunar and 1G. So that could be something that I think there are some platforms where that could be, even if it was a drop tower. So that's something certainly to look into. One of the other ways that we could go, and that I think that would benefit biological and physical systems, is back in 2014, I think there was a combustion lab workshop that had different themes, including spacecraft fire safety, but also other combustion science types of panels. And so I wanted to bring those up just to see whether there was, if looking at these and looking at some of the general categories, if this was something that we could maybe provide a little bit more background or suggestions to, back to Craig and everybody. So these were for the combustion lab workshop, these were the 6 themes, and the session leads are there. You can see some of the names are same as people who have been been talking today. But I was just wondering whether anything like in droplet sprays and aerosols or premixed flames or any of those categories would be, that there's anything in lunar gravity that would be particularly useful to conduct some of these tests in lunar gravity.
In the break, I had another thought. Maybe it might be interesting if you have some instruments inside the habitat. Maybe you could have when a fire breaks out. In many cases, it also is connected with a rise of pressure. If you might have using this rise of pressure so that some kind of membrane get cracked and releases some kind of, in quotes, air or CO2 or whatever, to get the environment richer with kind of atmosphere which is not supporting the flames. Just an idea to have some additional reservoir to get into this area, to drop the amount, not the amount, but the mixture, more CO2 rich, but not into a degree so that it is dangerous for the people inside.
Okay. I think what you run into frequently there is if you're going to be able to actually make the atmosphere so that it doesn't support combustion. That's an awful lot of gas. Or were you talking about, as you were starting to talk, I was thinking about well, I don't know how sensitive the pressure would be. I mean, my guess is that it doesn't rise that much, but if something is released and then that makes it much easier to detect, and you know exactly then what the signature is. But I guess if you had that, you could look at the pressure itself.
Yeah, because when I'm looking back to the Apollo accident of Apollo 1, you had an immediate rise of pressure, and if something would you could detect, maybe, I don't know, maybe you could use it as an additional kind of detection, as an additional thing of where you have some instruments or equipment specialized into certain environment, but it just comes from the basic idea from an atomic reactor. There was a kind of design in Germany when the burning sticks had, if you had a problem in the main part of your combustion chamber in an atomic reactor, there are the elements which fall down and stop the reaction, but you still have the temperature, and the temperature still is boiling the water around the Brennelemente, burning elements, and so the pressure gets higher, and you have three additional storages which have had in that days a metal membrane with some carving inside, so it's open like a Coke bottle, and at a certain kind of pressure, number one is getting opened and fills up the whole compartment again with water to cool it down. And this is something what works just by the principle of physics. And this is just the idea that this might be a possibility that you can get something into the environment just by this physical automation, that you don't have something to detect it. So just by the pure physics, you have a reaction to something what is getting out of control. This is the basic idea behind it. Yeah. How and where it could be used, I'm not so certain, but this might be a possibility to have it even in a point where your station or your habitat is not part of a manned mission. So that in that way, just an idea.
Yes, and that is one other issue that we really haven't touched on. But for a uncrewed period of flight, what are you doing as far as fire detection and suppression? I think the path that they're really kind of taking now is, shutting down equipment, keeping a minimal power levels, and only needed equipment on, and trying to decrease any risk that way. But there are pieces of the life support system that they do need to keep operational. There's thermal systems, thermal control systems, and we've suggested that during that period they could really do a raise nitrogen levels, stop adding oxygen, raise nitrogen levels up to the point where it wouldn't completely support combustion, or it's going to be a much smaller event and give them more time to respond. I think for a crewed mission, the kind of thing that you're talking about, it's probably a little drastic for the crew to respond not only to the fire, but to the way that it's being suppressed. Unless they can get out.
Yeah, it would be just in case of a real bad thing.
Yes,
everything
yes.
What gets out of the control of the crew.
Right. And whenever we talk about those kind of fires, or ask what about that, that's where they always vehicle manufacturers, designers, other materials and processes folks say, well, that's why we do all of our testing and only allow either non-flammable or fire resistant, flame resistant materials in a in a spacecraft. And the other thing that for a uncrewed portion is, I'm sure that they will have it so that everything is stowed, that normal, it's not like the crew just is going to get up and leave all their flammable or just their normal daily use materials out somewhere. So that's how I'm sure that's how they're going to say that that's how they're preventing a fire in an uncrewed state.
Have you ever taken a look to a kind of fire which does not need air oxygen, which getting out its support out of different liquids, which might be on the on the spacecraft?
I haven't, and I think that would fall under the you wouldn't really find that in a habitable or able to impact a habitable volume just because of those dangers, and it would be kind of addressed at a safety and an isolation level. What my thought is.
Yeah.
Yeah, they don't like hypergolic systems like that other than in the propellant. And those are outside.
Yeah.
Which actually, that's looking at Heather's conversation over here on the side, who has extra methane, I guess, that she's capturing, looking for uses for burning methane for other purposes in the Lunar Hab.
Could I just pipe in for just a second? Yeah, so I'm working on some designs for bioregenerative life support systems, and there's always an issue of what to do with the edible biomass, and of course there has been some work done with, say, inedible or using anaerobic biodigesters and or aerobic biodigesters, but the anaerobic produces methane that you easily capture, and they use a lot here on Earth to, in small communities and such, to use that biogas to cook with. And so if we could apply the same idea where we could recapture nutrients and turn the, the effluent would go back in as fertilizer and then burn off the methane in an oven for cooking. I know that an open flame on a burner would not be allowed, but I don't know why it wouldn't be possible if it's in a contained oven, which, in an enclosure, that would be something that would be considered. But I've been told by many people NASA would never allow that to occur. And I just don't really understand why, since we do flame research on ISS, it seems like it wouldn't be that hard to create an oven that would be safe.
It would be feasible. So the question is, in your energy cycle, do you make enough methane? One question is that you could, in the course of things, you make enough methane where it would be an adequate fuel supply to, for them to design an oven to do this. But in all likelihood, I mean, they probably would want to just reclaim the hydrogen from the methane through like the plasma pyrolysis system they're using from the CO2. They go through a Sabatier reactor, then they do which then makes methane. Then they're going to do a plasma pyrolysis of that to get some of the hydrogen off. So probably that's people would be interested in reclaiming the hydrogen.
Why do you think that it'd be more interesting? I guess what like one of the problems is, how do you get enough power for cooking and, doing things like baking or broiling where you need a particular type of heat for those cooking processes. So would you just use the hydrogen then to produce electricity for an electric oven? And would that be more efficient than just directly burning the methane?
Probably not more efficient, but they already have the hydrogen reclamation system already. It would be for other purposes, and then if you could feed into that with the extra gas.
The hydrogen for the water, and they
Right.
and they already. If you make CO2, then you got to then react the CO2 back to the current process goes through methane on the way to so in
Well, I mean, in this case, if you're producing enough, you're producing quite a bit of plant matter, and so the the CO2 that you're producing could be consumed by the plants as well. So I guess it's a question of what the right trade is. I guess I was just more interested in if it would be allowed and could be safely done. And it sounds like it's possible, and the question is whether it makes the most sense in a full system architecture.
Also, a non-flaming catalytic reactor would be possible with methane as well, and be possible with hydrogen, which might be considered safer since it's a surface reaction.
And you could use that for cooking as well. In this, you called it a non-catalytic.
Oh, like if you run the methane over the catalytic surface with oxygen and light it off, it should react on a catalytic surface, and that would produce a lot of heat as well. If your goal is only the heat and not necessarily the fire.
Great, thank you so much.
So Gary, looking at this list, it occurred to me that some people, such as those looking for ISRU, chemistry, and so on, we have to check with them to see if they have any need for combustion processes and what they're doing, I guess, and the many different tasks that people envision using the processing the regolith. I mean, how many of these actually would even consider using something that we would consider a conventional combustion process? I guess I don't even know.
I think the heater was a good one because we just listened to a talk about someone using radioactive batteries in order to heat the Lunar hab when if there's available fuel that's not being used for other reasons, you can just run that into a heater.
I guess what kind of heater are you? I saw the talk on the batteries.
I was thinking a catalytic heater.
Okay.
Multi-use fuels would be, the best idea, because then you can move your resources around as you deem certain things more important than others.
Well, as far as I understood, one of the reasons why to land on the south pole of the moon is the existing of water ice. Are there plans to try to get this ice to a use for rocket fuel, liquid oxygen, liquid hydrogen? Because if that's happened, this is also a point of fire danger, more or less. On one hand, on the other hand, it would be the fuel station for the solar system.
Yeah, they're definitely what the point of the water is to make the fuel, and the question is which or the oxidant for sure. And some concepts use a hydrogen rocket, others want to bring some carbon to make a methane rocket. So I guess they haven't closed that question. So
this is a very old idea. Now I'm talking as a museum history man. The first time that this idea came up is in the mid of 1924, as Valier, a co-worker and a colleague of Obert, came up with the idea, if we have reached the moon, then we need a little kind of space station. He put it in Lagrange 1. When Obert said it's not very good, but you know that why. And then we can have a little boat going up and down and searching there for water, not for gold. And then we have the solar system open for the big spaceships which never land on Earth. As old as this idea truly is, and I'm happy we're going to do that now as a museum folk. Sorry for that. was just a comment.
No, it's
No, we'll,
interesting historical comment, sure.
yeah, learn a lot by looking back.
We've been going to the moon for a long time. There and back and going back again.
One thing that it's not really on this combustion lab slide, but we were talking about detection and suppression methods and what would be applicable. It seemed like a lot of it was just thinking of a habitat, and I really haven't heard anything about what is planned for a pressurized rover, and whether that would have to be or should be different than what a habitat was. It doesn't, like, those are much smaller volumes. They are pressurized so that crew could live in it. That's part of the trade of them, I think. I don't know if anything would have to be different. I don't know in that case whether, I'm sure that the volume is at a premium, and trying to keep things as simple as possible. I'm thinking of fire detection and whether you'd have a mass spec in there, or whether you would just go to a standard smoke detector. I'm not sure whether anything different would be required.
I don't know, from a safety standpoint, I think you probably would want at least one small, smoke detector, probably a fan to suck air out if necessary. Just from a safety perspective, in a small volume like that, in case a fire did break out inside, to keep the, the air volume low. Because they have spacesuits in there. They probably have spacesuits, and they pull their helmets off when they're moving, but they'd be able to put their helmets back on, and you would be able to suck the air out, so they'd have time to do that. So in a situation like that, yeah, I think you would at least have to have some safety measures, and safety would require that. I'm just telling you from a safety standpoint, it would be required for fault tolerance purposes.
Sure.
I think in a situation like that, where you're so close to the lunar dust itself, it's probably more likely that if there was another choice for a fire detection system, not a smoke detector system, you'd probably want to go for that, because I have to imagine, I know there's a lot of effort going into how to handle, surface walk residue in whatever habitat there is. But if you're out roving around, it's going to be, you're not going to have that same robust system, I can't imagine. So
yeah,
perhaps
he's got a point there. I hate to interrupt, but even then, with the dust, tracking in and out of the vehicle, the smoke detector may mistake the dust being tracked in for a smoke particle. So that's possible too.
Sure. I don't know whether these are having a suit port, and how efficient those are.
Yeah, all that needs to be taken into consideration. Yeah, exactly. But there's going to have to be some kind of safety protocol in a small volume like that that's considered. And all of that just comes from the design factors that the design engineers put into it before safety takes a crack at it.
Okay.
Hey, Gary, do you know if there actually is, other than, I guess, the pictures that we saw today, is there a history of them wanting a pressurized vehicle that's has any progress made? Or is that 30, 40 years out? Or
I thought that, and I'm trying to remember where I just saw that presentation.
I think at ISIS, there was talk about that.
Right, but it was sooner than that, or more recent than that, where a pressurized rover was actually part of their habitat, kind of their mission ops, and I forget exactly how that, meaning part of the crew would be, if it was 4 crew, there could be 2 in the hab and 2 in the pressurized rover going out to do stuff, coming back, and I know they were talking about it, so I got the impression that it was something that would be, I don't know if it's 30 or 40 years, but certainly I think in their plans.
all right.
Yeah.
Well, I mean, at the same time, I guess we could go back to this similar idea where you mitigate some of the dust interactions with a smoke detector type fire detection system by ganging it up with a chemical detector, like we've talked about.
Sure.
Well,
Yeah.
This may definitely depend what kind of spacesuit you're going to use. If you have this type of system where you can dock your spacesuit more or less onto the rover or to the lab. Then you have the spacesuit outside, and you don't get anything inside the interior. So you have the regulate problem with the lungs and all that kind of things. You have it outside. On the other hand, as I get known, there is a new idea of spacesuit, which is not that way like we use it now. It's more or less straight on the body, and has some inner layers, but also close to the body, which get the heat and all that kind of stuff away. Total new design, and then you only need to have air in the helmet. And this would also be quite a good answer to the question, what happens if you, because this is more or less tailored right to the body. If you have a fire or whatever, if this one is fireproof, better clothes, and if you just need to get a helmet on, so you can evacuate the interior from air and oxygen, just as just was mentioned. Just put the helmet on, yeah, and having no problem with anything. But it would mean to wear this kind of new suit more or less all the time. And this kind of suit, I don't think it's easy just to jump in, or you need even something like to have the kind of exterior suit with a kind of locking to the rover. Then you need an additional airlock or something like that. And this is a major question, which way this will go. For the near future, I think it goes clearly to what we know of the kind of spacesuit. But for the next 10, 20 years, it might be the other thing they are just working on.
Yep, that's correct. Those kinds of suit ports have, pluses and minuses.
Yeah,
They're big, fairly large and heavy.
yes, because the regolith is critical to the lung. If you be there too long, you really might get into trouble. The occasion with Gene Cernan on Apollo 17, it's another thing, because he got regolith all over the body because of breaking the lunar speed record of John Young, and he tried also, and as a result he damaged his fender and got sprayed all over the body in an unusual extent over the while he was driving. So this is the main reason why he looks the way he was, adding all this lunar dust even to the body. And this is in my as far as I know, this is extremely dangerous because it's a situation like the miners in the 20s or even before, when they had no good regulations for the miners, and they damaged their lungs and died very early. And if we have someone on the moon for half a year or even a year, then this is one of the most important points, not to get the regolite into the living area.
Yeah, I agree.
Yeah, I know there are people, well, there are people on another session for this that are looking at that filtration and control.
Okay, sorry for that.
No, I think a lot of that
Not
is
at all. Yeah,
tomorrow.
it's totally legitimate. Yeah, it's a big issue, but that's why they're already looking at it.
Yeah, a lot of that is tomorrow, I think. The lunar dust properties and behavior and mitigation.
I found a link for an RV style rover in conjunction with JAXA. So it's out there on the internet for Artemis. So looks like a little buggy. So apparently they're looking at some interesting designs for a pressurized rover.
Yeah, I thought so.
Yeah, there's a picture of what the concept of what it looks like from some previous designs that they've been playing with. It's considered a lunar electric rover. So anyway, just thought I'd mention that.
Do you want to put it in the chat? As they're as they're talking more about outfitting a habitat and what they might do, I mean, my mind, I always have a kind of a microgravity science glove box or something like that of that size. Is that kind of the smallest that's necessary to do some some of the combustion or fire safety experiments that we've been talking about? Or what kind of facilities should we be pushing for a let's say a habitat experiment platform?
Also, a question is if it were like a MSG type box, which do you have a picture of that? Maybe not everyone's familiar with what that is. We could put a picture up.
Oh,
But we want to add in other capabilities, like is there a need for a pressurized MSG?
that's a good idea. I think
I think that's a big
probably
one.
should
I
be.
think people they've got to be looking at that already, I think, to some degree. I haven't found out who's looking at that yet, but I really suspect somebody has found that having a glove box is an important feature for any habitation module.
Yeah, this is Kevin Sato. So the need for a glove box of some sort, one for geology and also one for science, is being put into capability and architecture needs for a base camp science laboratory, and also we've been working on having, and it's actually in the documentation, a call out for an actual science laboratory itself inside the habitat. What hasn't been really determined is what type of glove box is going to be needed. Are they going to need a couple of different glove boxes, one for life sciences and one for physical sciences, given the different needs for both? And so right now is actually a really good time to put together concepts or ideas or requirement needs that you guys are going to need for a life sciences, or sorry, not for a glove box on the moon. And my thought is that you'll need to look at it from the perspective of how much power you're going to need. Does it need to be pressurized? And all sorts of stuff, because a glove box wording is there, but what it is and what it will do is not there. There's been some conversation that it could be very much the MSG on the moon. But I think one of the things they also want people to think about in terms of the architect folks that I'm working with, they would like to see things being able to be adapted, but also they want to make sure that it's not the same old where you guys are locked into what you had before, but they're looking at how do you evolve what you already have to something that is more capable, based on the lessons learned and how the science itself has progressed for potentially other needs. So yeah, that's definitely an important thing you should be talking about, but also, is there anything that you need as a standalone as well for your studies?
Yeah, that's great news, Kevin. Yeah, we'd love to get in contact with them.
Do you know if they're thinking about, on ISS, then there's the facilities like the glove box, but then there's also much larger systems like the combustion integrated rack, and that has inserts and everything. I would think that would be something that would be too large, at least for a habitat in the near future.
Yeah,
Is that
yeah, and that's the thing. I think it'll be important for you all to think about too. Is how do you maybe start with something miniaturized or so that you can use potentially on the CLIPS, the commercial lunar payload services via landers, and can you sort of miniaturize things down? For example, Ames is building Leah, which has inserts that they want to do for other types of experiments, and then gradually build up to something larger. The real impediment for the moon is going to be just getting stuff there, right?
Yeah.
Of any size that needs to be put together. There are some thoughts that the CLIPS vehicles can actually be used as delivery vehicles to bring things to the moon that are pre-positioned, and then the astronauts go over and get it and bring it over to the habitat to be assembled and installed. But I think the bottom line is not to just limit yourself saying it's got to be small. It's, I think, thinking about what is a suite of hardware or a suite of equipment that you can use of various size. And if it turns into, well, we need this amount of power, or we need this for combustion, and it's got to be this big, then we're going to need to know that as well in order so that they can then scar in things that are larger, or be able to know they're going to have to get logistics vehicles that can get to the moon and carry heavy things. So
Right.
I would say don't limit yourself, but and think sort of expansive.
So that brings up the point of Paul's proposal on the CLIPS lander combustion facility of whether if the astronauts can go harvest that and take it off when it's no longer in use and bring it back to the habitat, that actually makes a pretty nice pressure chamber.
You're going to hear a talk tomorrow by Zach Pertl on CLIPS, and hopefully we'll have time to have questions to him. But certainly Zach will be available for talks. And also at the pre-ASGSR meeting this year on November 2nd, we're notifying, and hopefully are going to get a lot of the CLIPS providers to that workshop, so to meet and talk with folks. So there's a lot of things, but the CLIPS office in SEO, or Exploration Science Strategy and Integration Office in SMD, they are wanting to get CLIPS providers to think more expansive than they have right now to provide more capabilities. So, all these thoughts are good as you guys start to build them. We'll get them communicated.
That's good to hear.
Hi, this is Jim Tian. I just want to put into my opinion. I think although people try very hard to do lunar or partial gravity on Earth, the quality of G is really not very good. Okay, not good enough from scientific point of view. So if we have something on the moon, like to expand the pores chamber to be somewhat larger, and it will be really nice from a scientific point of view and also from practical point of view. We really should consider that.
So I guess what you just said in your opinion that any of the Earth-based platforms aren't good enough to do anything. I guess just what you said, scientific.
No, they are good, but to give example, we fly airplane. We have G jitter. Now with the G jitter, some of the limit could be affected. Okay, I would say in the bulk it may be very useful, but in terms of scientifically, the quality is not as good. Okay, besides there's a limitation of time. There's really limitation of time, and if you're trying to get, for example, upward spread limit, I think it's very difficult in 20 seconds, even with the thinnest material such as Kimwipe. Now, if you have any other material, and it would be good to have a G level steady for longer period of time. And so a device like what Paul proposed, and it would be really useful if it can be permanent on the moon. The only concern I have is right now they may be limited by its height. So if you have a design which can be expanded a little bit higher, if you're trying to settle all the time at the moon, would be nice. But I would say we are limited by not by time, okay, not by time. And you already mentioned, if we have a rotating stuff, we have the complication of Coriolis force, and even with what you propose, it's still time is still limited. Okay, and so what a permanent device on the moon is really good from component science point of view, and also I think from practical safety point of view. I strongly want to push for this. Yeah.
Is Kevin still on?
Yeah, I'm still here.
Oh, I was just wondering whether in the report that we are to be producing out of this, would that be a good way to communicate kind of just maybe some initial thoughts on capabilities of this glove box type facility?
Yes, absolutely.
Okay. I'll have to work on that.
Well, and please keep in mind you can use the glove box also somehow as a repair box.
So that's somewhat what the crew member here is doing. She's actually assembling samples, so she's using it as a workbench as well. And there's actually some pieces that kind of float around that really do need to be captured, and so she is kind of using it as a repair box.
Hey, Paul, can I ask, I saw your design and it's really impressive. How many, so in one loading, how many tests are you imagining you get out of that?
Right now, it's still TBD, but I think we decided on 4 test samples. And the limit there is really the amount of gas we can bring, because we have to fill a chamber for each test. So we're limited in how many pressurized gas bottles we can bring. But right now we're thinking 4. I mean, it might be plus or minus 1 or 2, I guess. Hopefully not minus.
Okay. All right. Right. Because that sounds really reasonable, right? You can get a good slug of information that way. But I think when we're looking at the glove box or, SIR or something like that, the real advantage there is that you're trading off a larger, heavier facility that can be run remotely without time of somebody, right? Not restocking it, not running it, not paying much attention to it at all. So, I mean, that becomes another key selling point of something more integrated, more bigger, right? Because
Yeah.
four tests is great, but if you want 20 tests or 80 tests, that's a lot of effort.
Yeah,
So it's a good
for
place to
sure.
start. Yeah. But if we're going to make that argument about having, a substantially sized, something that, is a real expenditure of resources, then I think that's an argument that needs to be fit in there.
I see it as sort of an organic thing. We're going to do the best we can with the facilities and the capabilities we have. So initially, if we can be a hitchhiker on one of these lunar robotic vehicles, and we will do that. Eventually, when there's people there, if there's a facility up there like a glove box that will be open to doing, many combustion tests like they do currently, like you're watching, then that would be something we would do at that point. But we
Right.
do want to get the story out there so people have it in mind that we want to get there. Although we can't do that right from the beginning.
Sure, I completely agree. Right, it's the thing that you need that information too up front in order to design the larger set of tests too. So, I mean, it totally fits, and I think organically is a great word for it. But as the opportunity for something to be built up, to have more space, to have more whatever, more everything, right? Then within this 10-year window, if we're looking to shoot for something bigger, for real change, for real, then I think asking for a glove box isn't asking for the same old thing. It's asking for something necessary that is going to take that next step. If that makes any sense.
Yeah, for sure. Since we're getting close to, I just leave you with this thought. This is like one idea for a facility. I would encourage people to think of other potential ideas for experiments, both like Gary said at the beginning, looking for other facilities that we could use. It might be something else that we haven't really thought of. So just to keep the narrative going in a sense that we can. There's other ways we can get useful tests in other potential facilities. Just if people have other ideas, please let us know.
Yeah, this is Kevin. One other thought too, and this comes from the life sciences side, is that even though we'll be at 1/6 gravity, they're still looking at the opportunities to bring centrifuges onto the moon, because now they can rather than trying to simulate the lower gravity on Earth, they can actually now spin things up, which they have a little more control over, to do 1G controls, but also 1/3 gravity as well for Martian. And then also, obviously, one thing you guys might want to consider too is, as you're doing work on the moon, what life sciences is interested in doing is using Moon, Earth, and ISS as controls now to tease out variations and differences between the environment of deep space and Moon versus, say, pure microgravity. And so that requires potentially the same equipment in both places, so that you reduce the variability between equipment differences that could occur. So if you're thinking about 1/3, you might also want to think about, are there centrifuges that you might want to use on for physical sciences studies on the moon to mimic 1/3 gravity, where it might be a lot easier to study, and also with the 1G control as well.
Sure. Are they, just trying to think, yes, you're starting lower, you're starting at 1/6 and then spinning up from there. But they need longer time than what you could get or would get in a drop tower. Is that, or
Yes.
or another? Do you know how long they would need that?
For on the life sciences side, we've done experiments that have spun for weeks
Ah,
at a time, right? Because for us, a drop tower would provide, or biology would provide sort of immediate early events that you might be seeing change that you don't get if you're trying to do it over a long duration of period of time.
mhm.
But when you're looking at adaptation or acclimation, or whether a change is permanent or whether it's constant, you need a longer duration spin time. So you know, that's why we tend to not use the parabolic or
Sure,
the drop towers.
sure.
However, Rob Furl, who's one of the co-chairs for the decadal, he has done those studies with plants, and they're seeing some really interesting results. So it just hasn't been used as much as it can be.
Okay.
All right, good. Yeah, we'll keep that in mind. And it just, a crazy thought occurred to me that we could imagine someday having a drop tower on the moon even. You make it 1/6 the height of an Earth drop tower. It's 1/6 the gravity. So, of course, it's sort of ridiculous, but it could happen way out there for some reason.
Sure, you'd have to find a volcanic tube or something.
So you wouldn't need
Okay,
you wouldn't need the drop tower. You could just a sounding rocket would be very easy on the moon. Not much propulsion is needed.
Yeah, you could just throw something back and forth between two astronauts.
Right. Make a golf ball sized experiment. Yeah. And hope you find it.
Very good.
okay. Well, we're coming up on the time, on 4:30, and I think we've had, we started a lot with fire safety and a lot of discussion on detection and suppression, and I think that some of the talk about heaters and how to well, it could even be as far as some of the ISRU applications for reacting systems would be some place that we could get some traction with. And we talked about the pressurized rover versus a habitat, and then spend some time on facilities and the kinds of things that we would want to have there. So I think we certainly covered a lot of ground in these twos in this breakout session, the two sessions we had. I don't know, did you want to say something, David?
No, not at this point. I think you guys, they've got a lot of interesting thoughts and suggestions. So I think it's really been, we'll put it to use.
Okay. Paul, do you have anything?
Oh, no, I just wanted to make the reminder, Kevin said for tomorrow, we start again at 10 o'clock Eastern time. And the keynote speaker is Harrison Schmidt, who is of course, an Apollo astronaut. So it should be a very interesting talk tomorrow.
Yep.
Well, maybe I have a suggestion again for the rover. Maybe on the bottom of the rover, you may even have a glass and two gloves, so that you might be even to have some sample tracking or closer looking even from the rover inside. as one possibility, or even if you have something also to repair on the outside, you could do it from the inside without using a spacesuit. Just jumped into my mind.
Haven't heard of that concept, but
No, it
could be useful.
just came as your glove box. Use the inside rover and have the glove box outside. Just looking through a window and having your laying on the ground and getting your fingers on with a glove straight to the surface.
Yeah.
Instead of kneeing you down, getting all the dust on the suit, might be also an opportunity if we have a pressurized rover.
That's a reasonable idea. It's sort of like the deep sea submersibles when they
Yeah.
gather samples.
Yeah. Well.
Okay. Well, like I said, it's 4:30. I'd like to thank everybody for participating. I think it's been a good discussion, and we will be putting together a workshop report from this breakout session, and we'll try to capture everything that that we've been talking about. So thank you very much.
Thank you. It was a pleasure for me.
And good evening.
Good evening.
Thank you.
Thanks, everybody. Have a good night.
Yep. Thank you.
Thanks, everyone.
Thank you.
Thanks, bye.
Thanks.
Bye bye.